Okay, what we're going to do is we're going to model polynomials. That means given some information about a polynomial, we're going to write the starting equation. And we've already done that once in this for polynomials, but those were the ones that had a leading coefficient of 1. If you remember, those were the kind that what would happen is, they would give us like a 0 of 2, and then they would give us a 0 of 1, and then they may give us a 0 of 1 minus the square root of 2, and we would have to know that there was a complex that there was a conjugate of that 1 plus the square root of 2, and then we would put those in factored form and multiply them together. This is similar, but we're not going to have the imaginary roots and the rational roots like this. This is going to be a little simpler, and the a value now is not necessarily going to be 1. So this is the same procedure we have used when we did quadratics this way, squares. So it's not really too hard. So what we're going to do is take a look at, I guess, what I have up here. So it says, unlike writing equations already done in this chapter, the leading coefficient does not have to be 1 here. It's going to be a, and we have to find it. We will need to either look at a graph and find the zeros from the graph and one other point. Or they will give us a list of the zeros and one other point. So that's what I just said, okay, for however many zeros there are, we're going to express them as factors. So if I had zeros of P, Q, R, and T, of course, you just subtract those to get the factors, okay? So what we're going to do is we need to find the zeros and put those into factored form. Then we need to have some other point that the graph passes through. Put that in for x and y. And then all we'll have left that we don't know is a, and we'll calculate the a and then write it back into its function. So here's an example. This is really pretty easy. You guys have done this before. So let's look at this graph. We have zeros right here. So I have the zeros are I have a 0 at a -4 for x. I have a 0 at a 1 for x. And I have a 0 at 3 for x. Okay, I also know that it passes through the point 0 and -6. Okay, so let's go ahead and write this. So what I'm going to have is I'm going to have y is equal to, now I'm going to subtract my zeros, right? So for the first 0 at a -4, now there's going to be an a out there. I'm going to subtract the -4, that'd be x plus 4. Then I'm going to have x minus 1, x minus 3. And what I'm going to do next is to find a, I have to be able to put a number in for x and y. And I have that. That's this other point. So the y value is a -6. So let's put a -6 in for y. And let's put the 0 in for x, because this point has to satisfy this equation. It has to work in there because it's on the curve. So I would have 0 plus 4, 0 minus 1, 0 minus 3. So a -6 is equal to a. 0 plus 4 is 4. 0 minus 1 is a -1. 0 minus 3 is a -3. Continuing to simplify this, I have a -6 is equal to 4. That's a -4 times 3, 12a. So now I'm going to divide both sides by that 12, and since I'm running out of room, I'm going to put it over here. I would have a is equal to a -6 over 12 is a -1/2. So I'm ready to write the equation. Y is equal to a -1/2, and now it's going to be this form that I use here, right? Because I want to be able to plug in any x and y. So I'm going to go ahead and leave my x's now as x's. So x plus 4, x minus 1, x minus 3. And that's the equation. Okay, for the second example, they give us a graph. Like I said, they could have given us a set of points, and we would have to find the zeros out of the set of points. Of course, the zeros would be the points that have the y value equal to 0. And then if this was a list, it could be a little confusing, because if the x-coordinate is 0, then that obviously is not a 0. That's a point that the line passes through. Okay, so what we have is, let's go ahead and write the form for our, write the equation by putting in the zeros, by subtracting the zeros. So I would have y is equal to a, my first 0. Well, let's just list the zeros. Let's do that as the first step. Okay, so I'm going to list the zeros. Zeros are going to be, I have a 0 at a -3. I have a 0 at 1. And I have a 0 at 2. The point that the curve passes through, that I'm going to put in for x and y, is the point 0, 3. So now we're ready to write the line, or the curve. So y is equal to a times each one of those zeros subtracted. So that would be x plus 3, x minus 1, and x minus 2. Now that I've got my zeros written into the equation, I'm going to go ahead and plug in the value of the point that it passes through for x and y, because I know that that curve has to pass through that point. So it has to be, the equation has to be true with the value of that point in the equation. So I'm going to go ahead and put 3 for y. I'm going to put 0 for x. And now I'm going to find out the value of a. So a times 3 times a minus 1 times a minus 2. 3 is equal to, I've got a minus 2 times a minus 1. That's a positive 2 times 3 is 6a. So if I divide by 6, I get 1/2 is equal to a. So now that I found the value of a, I can put it back into my equation that has the x and y, because obviously the end equation has to have x and y. So y is equal to 1/2 x plus 3, x minus 1, x minus 2. And I've written the equation. That's a model.